Population. The first step in choosing the right sampling technique is to clearly define your population. The population is the entire group of people or items you want to study. For example, you are writing a thesis about how factory workers follow new safety procedures on the production line. Your population could be all employees working in production areas across multiple factories in your city. It is important to specify who you are including and who you are excluding. Are you studying only full-time workers, or also part-time employees? Are temporary contract workers included? Clearly defining the population ensures that the sample you select represents the group you want to study accurately. This step is essential because the wrong definition of population can lead to biased results and reduce the credibility of your research. Research objectives. Your research objective plays a key role in determining the sampling technique. You must decide whether your goal is to generalize findings to the entire population or to gain detailed insights from specific individuals. For instance, if your thesis aims to measure the level of compliance with safety procedures across all employees, you need a sample that represents the whole population. This requires probability sampling methods. However, if your objective is to understand why certain employees follow procedures while others do not, you might only need a small, targeted group of participants. It makes non-probability sampling methods more suitable. Clearly linking your research objective to your sampling technique ensures that your data will answer your research questions effectively. Probability sampling techniques. Probability sampling ensures that every member of the population has a known, non-zero chance of being selected. This is important when you want to generalize your findings. Simple random sampling. In this method, every employee has the same chance of being selected. For example, if your population has 1,000 factory workers, you can number them from 1 to 1,000 and randomly pick 100 employees using a random number generator. This method is fair and reduces bias because everyone has an equal chance to be included. Use this method when your population is homogeneous, meaning employees have similar characteristics, and you want a truly random, representative sample for statistical analysis. Systematic sampling. Here, you pick every nth employee from a list. For example, if you want 100 employees from 1,000, you select every 10th person on an employee list. This method is fast and easy, especially for large populations. Use systematic sampling when your population is large and ordered, and you want a quick way to select a sample without generating random numbers. Stratified sampling. In this method, you divide employees into groups based on characteristics like department, role, or experience. Then you randomly select employees from each group based on their size. For example, if the factory has 500 production workers, 300 maintenance workers, and 200 administrative staff, you take a proportional number from each department to match their size in the population. Use stratified sampling when your population is diverse, and you want to make sure all important subgroups are represented, which improves accuracy and fairness. Cluster sampling. Here, you divide the population into clusters, such as different factory locations. Then you randomly select a few clusters and include all employees from those clusters. For example, if you study 10 factory sites, you could randomly choose 2 factories and include all their employees. Use cluster sampling when the population is spread out in different locations or it is expensive or difficult to reach everyone, because it is more practical and saves time. Data analysis. These probability methods allow you to perform statistical tests like averages, correlations, and regression accurately. They reduce bias and make it possible to generalize your findings to the whole population. Non-probability sampling techniques. Non-probability sampling does not give every member of the population a known chance of being selected. This method is suitable for studies that focus on detailed experiences or when probability sampling is not practical. Convenience sampling. In convenience sampling, you select participants who are easiest to reach. For example, if you are studying how factory workers follow safety procedures, you might interview employees who are available during your visit. Use convenience sampling when you want preliminary data, when the study is exploratory, or when you need general ideas before doing a larger study. It is not suitable for making conclusions about the whole population because it may not represent everyone fairly. Purposive sampling. In purposive sampling, you choose participants who have specific qualities or experiences important to your study. For example, if your thesis studies how supervisors enforce safety rules, you would only include supervisors, not regular employees. Use purposive sampling when you need expert opinions, when studying a special group, or when only a specific type of participant can provide the information you need. This method is ideal for understanding unique perspectives that are critical to your research question. Snowball sampling. Snowball sampling is when your participants help you find other participants. For example, if you are studying employees who follow unusual safety practices, you start with a few employees and ask them to refer others with similar experiences. This is useful for hard-to-reach or specialized groups. Use snowball sampling when the population is small, hidden, or difficult to find, such as employees with rare knowledge or unique experiences. It helps you reach people you might not find otherwise, but it may not represent the entire population. Quota sampling. Quota sampling ensures that certain groups in your population are proportionally represented. For example, if your population has 50 production workers, 30 maintenance workers, and 20 supervisors, you select participants to match these proportions. This makes sure the sample reflects the population structure. Though participants are not randomly selected, use quota sampling when you want balanced representation of subgroups in your study, but cannot do random sampling. It is helpful when group differences are important to your research, like comparing different departments or roles. Data analysis considerations. Non-probability sampling is often used for descriptive or qualitative studies. The data can be analyzed using thematic analysis, coding, or frequency counts to identify patterns and insights. However, the results cannot be generalized to the whole population because not everyone had a chance to be selected. This type of sampling is most useful when your goal is understanding specific experiences, behaviors, or opinions, not producing exact numbers for the entire population. Choosing sampling for quantitative versus qualitative research. The type of research you are doing also affects the sampling technique. Quantitative research usually requires probability sampling because the goal is to generalize results and perform statistical analysis. On the other hand, qualitative research focuses on understanding experiences, motivations, and perceptions, so non-probability sampling is usually preferred. Common mistakes to avoid when choosing a sample. Selection bias. This happens when the people you choose for your study do not represent the whole group. For example, if your thesis studies how factory workers follow safety rules but you only survey workers from one department, your results may not show what all employees do. Sampling error. Even with a good sampling method, the sample may naturally be slightly different from the population. For example, if you randomly select 50 employees out of 1,000, their responses may not be exactly the same as all 1,000. This is normal, but it should be considered when analyzing your results. Non-response bias. Sometimes people in your sample do not respond. For example, if some employees ignore your survey, your results may only show the opinions of those who responded, which can give a wrong picture. Sampling frame bias. This happens if your list of participants is incomplete or outdated. For example, if your list of employees misses new hires, your sample will not represent the full population. Voluntary response bias. This occurs when participants choose themselves to take part. For example, if only the employees who always follow safety rules answer your survey, your results will not show the opinions of those who do not follow rules. Undercoverage bias. Some groups in the population may be left out. For example, if your thesis only surveys full-time workers and ignores part-time or temporary workers, your results will be incomplete. Overgeneralization. This happens when you make broad statements based on a small or unrepresentative sample. For example, saying all factory workers follow safety rules based on a few interviews is misleading. By avoiding these mistakes, your sample will better reflect the population, and your thesis results will be more accurate and trustworthy.